Let's go ahead and take a look at the viscosity of oils. So today we're going to look at different petroleum-based oils. And as you know, viscosity is the resistance of a liquid to flow. So the more viscosity something has, the thicker it is and the slower it's going to be pouring or flowing out of a container. So our contraption that we have today is right here. There are different colors representing the different colors of the tabs: red, black, blue, green, and gray. Okay, so that will relate to your lab manual. In your lab manual, you will also have an area to record down the times. And so we're going to do 5 trials for each of the 5 colors, get the average, and then create a comparative bar or column graph based on our data that we're going to be collecting right now. So we're going to start with the red tube, and in the red tube there is a steel marble that we're going to be measuring the time it takes for it to travel the distance of our tube. I have a magnet here that will catch it each time. All right, so here comes trial 1. And our number is 1.7 seconds. Let's go ahead and reset. Trial 2. 1.79. Trial number 3. 1.84. Trial number 4. 1.63. And final 5. 1.68. So that is for the red tube. You'll add those up and then divide by 5 to get the average that you will be making a graph. All right, our next one is the black colored tube. Here we go. 3.49. 3.40. 3.40. 3.38. 3.14. That is for the black tube. Again, same thing. You'll add those up, divide by 5, create your average. All right, next tube, the blue tube. 4.84. 4.53. 4.31. 4.41. And 4.43. All right, our next one, the green tube. Here we go, trial 1. 5.70. 5.41. 5.43. 5.32. And last trial. 5.59. Again, add them up, divide by 5 to get your average. last one, the gray tube. $7.32. $7.35. $7.52. $6.77. And 6.80. Again, as you've done before, take your 5 numbers, add them up, divide by 5 to get your average, and you'll be creating a comparative bar graph or column graph on those 5 different types of petroleum oil. All right, for part 2, activity 2, very similar thing. We're still measuring viscosity, that resistance of the liquid to flow, but this time we're going to be using a much larger tube here. As you can see, this tube is about 53 centimeters in length, and if you look at your data table, you will see all of the data filled out for the distance, and that's why these are marked as well, because this is the distance that we're going to be measuring how long it takes for each of the bubbles to travel the specific distance. Now we're only going to do one at each distance and then one at the total distance. So the first thing we're going to do is find out how long it takes for this bubble to travel from the bottom to the top, or the top to the bottom. So let's go ahead and invert this. We'll follow the tube. I'll start the timer. And the bubble is slowly traveling up to the top. All right, and the number is 7.4. So 7.4 seconds for the bubble to travel the length of the tube. So let's do the same thing for the other 2 tubes, for the blue and the green. So let's do green next. It's next on our data table. So here we go. Let's do the green one. We'll invert it. Start the timer. Bubble's traveling much slower than the previous one did. Almost to the top. 19.2. 19.2 seconds there. And our last one, the blue, here we go. Timer is started. Bubbling is traveling up. 11.2. 11.2. All right, so we have our maximum time for each of the 3 bubbles. And we also have the maximum distance, which is 53 centimeters. So now we're going to go back to the red. And this time we're going to do 40 centimeters. So from here to this mark right here. Here we go. And I'll stop it once the bubble gets to that point. 4.9. 4.9. We'll do the same measurement on the green. We're doing 40 centimeters in distance. And here comes the bubble. I'll stop it at 40. 14.2. And lastly, our blue at 40. Here we go. 8.6. 8.6. All right, back to our red at 30. Here we go. 3.6. green at 30. It's at 20. $9.9. Blue at 30. $5.5. Comes the red again. Do red at 20. This one here. This one's going to go quick, so I'm going to be fast here. 1.8. Green at 20. 6.6. And then blue at 20. 3 even, 3 seconds. All right, our last 3, we have red at 10. Here we go. 0.9. Green at 10. 2.5. Blue at 10. 1.5. All right, so now we have all of our data for the larger tubes. So we have all that here. Again, this time you're going to create a scatter plot graph. Now this is a line graph, except you have a bunch of different colors. So you're going to want to use a colored pencil if you're doing it by hand, or if you're going to do it on the computer, use your color code. Use green dots for the green tube, blue dots for the blue tube, red dots for the red tube. So you'll have all 15 points on the graph, and you're going to create what's called a trend line. And that will enable you to determine data for a point that you might not have collected. Like we didn't collect 35 centimeters on our tube, which would be, here's 10, 20, 35. If we wanted to know how long it took for there, you can very simply use your trend line and make a good prediction on how to do that based on your current data and your trend line that you're going to add onto your graph. So that is your graphs for viscosity of oil.